do this. Okay, so today we are going to be talking about where we were doing in the last lesson, and that is circle geometry. And circle geometry is in paper 2. It's a pretty decent chunk of paper 2. And in the last lesson, we were basically learning about the 3 main groups of theorems that we need to know about. And I said to you, group 1 was circles and the center. And then I said group 2 of theorems was circles and cyclic quads. And then the third group was circles and tangents. And now each of these containers or groups, they contain other theorems that we need to know. So just to kind of give you a little reminder, I'm not going to do all of them now, but one of the theorems that came up in the last lesson was if you have a circle and the center and you have a chord and the line from the center is to, let's say, the midpoint of the chord, what else do we then know? If we know there's a line from the center to the midpoint of a chord, what else do we know about this, this particular circle and chord combination? I'd love to see in the chat. We're just doing a little recap. If there's a line from the center to the midpoint of the chord, what do we know? What does that theorem tell us? Okay, so that the line, basically what I see Bambi and Teddy have, and Njongo have all said it, if you've got a line from the center perpendicular to a chord, sorry, to the midpoint of a chord, you know that it's perpendicular. An example of the cyclic quad one would be if you have a circle and you have a quadrilateral on that circle or a cyclic quad, the external angle of a cyclic quad is equal to the interior opposite. So that's one of the ones to do with that. And then in this category over here, and we're going to spend a bit more time working with tangents today, a very famous one is the tan chord theorem, which I'm going to try and get a tangent that just touches it slightly. So if you've got a tangent and you've got an angle between the tangent and a chord, that chord can form an angle at the circumference. And we say that the angle between the tan and the chord, so that's this angle, is equal to the angle in the alternate segments over here. It's called the tan chord. And then the other quite important, I'll do a couple of tangent ones. The other tangent theorem says, if we've got tangents from a common point, so these are tangents, then these two will be equal. And then the other tangent theorem that we deal with, why is my thing being so weird? Let me just move it out the way. The other tangent theorem is that if you've got a tangent, in fact, why don't you tell me what this is? If you've got a line from the center to the point of tangency, what do we know about that relationship? I want to know in the chat. What do you guys think? What's important when you've got a tangent and you've got a line from the center or a radius and it's meeting the point of tangency? What do we know about that relationship? You can do it. Well, this one equals 180, but the theorem says something else. I don't want to give it away yet. I think Malwazi's onto something. That line is perpendicular to the tangent. Yes, this is called the tan perpendicular to radius theorem. And basically, if you have this situation, this will be a 90-degree angle. And its shorthand is tan perpendicular to radius or tan perpendicular to diameter. Okay, so that was just a little, refresher from the last lesson. There are other theorems that you need to know. Are there any questions before we get going, or anything you want me to clarify for you? Otherwise, we're going to go straight into some more simple questions and we'll build up the complexity as we go. Okay, so the goal for today is just to get better knowledge of the theorems and applying them to exam types questions. Segments and chords, sir. Okay. I think you're thinking about the angles in the same segment. Now, this is going to come from the second kind of group 2, and it's cyclic quads. And I think, Teddy, you're probably thinking about the butterfly theorem. And what happens is if you've got a chord and it makes an angle up here, so let's say you get that, and then that same chord makes an angle up here, those two angles over there are equal. And we say they're equal because it's angles in the same segment. And it turns out that we can also, that these two over here, that one over there and that one over there is going to be equal. And the reason it's in group 2 is you can see that this depends on there being a cyclic quad. So there's the butterfly essentially is a cyclic quad. There's 4 points. Okay, so I hope that was helpful, Teddy, just in doing a little recap. Let's see some of these in actual use. So let's go back to the beginning and let's try and solve in this question for y and z. And when you've solved it, I'd love someone to come online, when you've had a bit of time to think about it, and tell me how they got z and y. So you're given a circle. You need to think about what theorems or facts will be involved. And then you need to think about what value do you think you would get for y and z. Let's do this. And then I want to hear some human voices to tell me the reasons. What shapes do we think we know in this one? Can you hear me, Lebo? I think I had a bit of a moment there where I left the building.
Oh, yes, I can hear you, Mr. Days.
Okay, cool.
I didn't realize.
No, but that's good. That's a good time to, I think my internet connection just went wonky. Okay, I see good things coming through from Nolwazi, from Bambi, Zanele. I want to know, I want someone to come online and just give me a little talk through of how they solved this one. Who wants to chat? Come on, guys. We've got to, okay, let's go. Can we unmute Njongo? Talk me through your thinking, Njongo.
Can you hear me, sir?
Perfectly, perfectly.
So what I did first is I saw that y equals 68 because they're in the same segment.
Perfect. So angles, I've got my thing in the way here, angles in same segment. And that was the thing I actually just showed you in the previous thing. Yeah, perfect. It's the butterfly shape here.
Yes, then z was just simply angles are 2 times at the circumference. So I divided 68 by 2.
Aha. Now, I agree with you on the angle at the center, angle at the circumference, but I'm looking at the drawing and it looks to me like this is an acute angle and this one is like a bigger angle.
Obtuse. So, okay, wait. So
what do you think?
Maybe z, let's say z, the z with the z, it's z1, then the o is z2, So O is equal to 34, then 34 minus 360. 34 minus 360 is Z is 326.
Aha. Okay. Almost. So what I think
Is it?
is, can you see this arrowhead here? I think that this angle over here is twice the size, okay, of 68. So it's going to be 68 times 2. Can you get me the answer on that one?
Okay, 68 times 2. That's 136.
Perfect. So that would be 136, and it would be, like you said, angle at center equals twice angle at circumference. So angle at center equals twice angle at circumference. Lovely. Thank you so much. Give me a thumbs up if you're all okay with that. Just want to get a quick check-in with the group. You follow my thinking? So one of the things I want to make sure that we're clear on is that the angle at the center is always going to be bigger than the one at the circumference. You can kind of visually see it, but I just want to reinforce that. Yeah. Okay. Awesome. Let's go on to the next question. So in this question, I want everyone to think about what is involved in the question. So what are you given? I will tell you that these two are tangents. And now I want you to try and find for me the value of F and the value of G. So I'm going to give you some time now, and then we're going to see what people get for F and G. Think about what theorems are involved and see what you can do. Let's do it. Maybe someone can give us a hint in the chat. What theorems might be useful in this question? I think of this theorem as like the world being given a hug, or like a Pac-Man.
Kelani seems to have an idea.
Aha. Let's go unmute Amakalani.
So I think you can say 2F, because I don't know how to explain this. The tangents are gonna have equal angles at C and A. So I think you can say 2F plus 80 equals 180 degrees, and then get the answer of F, and then the answer of F is going to be the angle there. I don't know.
Okay, I like what you were saying there. So I think tangents from a common point called B is the really helpful thing here. There's a couple of ways you can write it, but especially knowing that this angle and this angle are both F is important. And then, like you said, you know that if there's two Fs and 80, this is a triangle. So that seems like a good way to go. Okay, I like that. There are some mentions of tan chord in the chat, but the problem with tan, well, there's no problem, but normally with tan chord, you'd make your angle kind of at the circumference like that. So there is tan chord theorems, but I don't see how helpful they are right now, although I could be missing something. But for the moment, I liked where Amakalani was going with the triangle and the tangents from a common point. And the question of G is an interesting one, though, how we get to G. Maybe there is some tan chord going on there. Let me have a think about that. Ooh, there's another theorem in the house I just remembered. This is a good question. Okay, so when you get the answer for F, put it in the chat. Otherwise, I'm going to show you now. Okay, so Jessica and Horiva, I see you've got some comments. Jessica, I think you're very much on the right track, because if I take away 80 from both sides, I get 2F is 100. And if I divide by 2, it's going to be 50. So F is 50. And Bambi agrees. So we've got F is 50, which I like. Now, what I want to know is, how do I get G involved? That's a little bit more sneaky. Can anybody think of a theorem that involves tangents? And is there a center of the circle involved, maybe? Who else can think of something?
We have a hand from Teddy, Mr. S.
Yes, Teddy, what do you noticed?
Afternoon, sir.
Hello.
This one is a bit tricky, but is it possible to say that angle O,
Yes.
like the inside of it, is 100? A cyclic
Aha.
a theorem.
Okay.
What about it?
The problem is, a cyclic quad needs to have all 4 of its vertices on the edge of the circle.
Oh, okay.
But I liked what you were thinking, but the problem is I don't see this being a cyclic quad.
Yeah.
But I liked your idea.
Okay, sir.
Now, I saw Horiva said G and F are alternate angles, but the problem is alternate angles are only equal when we have parallel lines, and I don't see any parallel lines. Okay, I'm going to give you a hint. Wasn't there a theorem at the beginning of the lesson that dealt with radiuses? Now, I suppose in this question, we should have said this is the center, but I think there's something quite special about this angle over here. Teddy, yeah. Did you raise your hand?
Yes, I did. The angles in a circle, so that one will be 90 if I'm right.
Yes.
Oh, the inside.
Yeah. It's the tan perpendicular to the radius theorem, right? So this is 90 degrees, and this would also be 90 degrees. So what I'm going to say is angle OCB is equal to 90, and the reason is going to be tan perpendicular to the radius. So now I know that this is 90, but I think if I know the whole thing is 90, and I know this is 50, I think I know what this angle over here is going to be. What do you think that angle over there is going to be in the chat? Yes, it's 40 degrees. Loving it, people, loving it. Because 90 minus 50 is 40. So we can say that OCA is 40. And that's just basically because we went 90 minus 50. And then the last thing is, what is G going to be? What's the relationship between the first black dot and the second black dot? Yeah, it's going to be 40. And what's the reason? The reason is these are radii. So if you look at this, this is a circle. And so the reason is going to be radii. Love it. Look at that, Bambi. Look at that, Nolwazi. Bonolo, brilliant. Okay, just give me another, I know that was a bit of a toughie. Give me a thumbs up if you're feeling good. Thumbs down if that was a bit much. Just want to get a feel for the group. Let the people speak or vote. You can be honest, don't worry. It's like up, down, just to give me a feel for how it's going. Okay. Let us sneak in one more before the break. Okay. Let's do this one before the break. So it says in this question that OT is a radius. So OT is a radius. Here's OT. AB is a tangent. So this is a tangent. Find the unknown angles. And the unknown angles are going to be X, Y, and Z. And so we'll do this question as best we can. And then we will take a halftime break. I'd love to hear some feedback, though, from the people of the class. You can put your hand up, we can have a conversation, or you can pop it in the chats. Teddy, oh, I see what you, yep, Teddy, I think you're on the right track. Who else has some ideas? Maybe you can just pop your hand up. You can just tell us audibly. Sometimes that's a bit quicker. Like who are some ideas about getting X? X seems a bit hidden away there. Like I understand how to get Y. There's a theorem that I'm remembering that can help me with Y, but X is a bit hidden away. And I'm wondering what I need to do there. What do you think, Owami and Njongo? What do you think? You could, William, I think that, and when I say group one, I suppose I should say there's a bunch of theorems in group one, but I would definitely involve group one and group three here. There isn't cyclic quads, but there's definitely tangents and there's definitely centers of the circle, right? So I think that I agree with Teddy that Y has to be 90 degrees because it's angle in a semicircle, which is kind of from the first group of theorems. So Y equals 90 degrees, and we say angle in a semicircle. Okay, so that's taken care of. Now Z is actually not too bad, and this was also said in the chat. If you know that this is 30 and this is 90, Z has to be 60 because of the sum of angles in a triangle. So we know that this is 60. What we don't know is this pesky X over here. And that's why I'd love someone to come online and raise their hand and tell me, or in the chat. I need someone to help.
Teddy
Okay.
and William.
Okay. Oh, there's lots of hands there. Okay, let's try someone different this time. My people are coming through. Njongo, what do you think we should do to get hold of X here?
So I'm not sure,
Okay.
but like I'm just thinking.
What
Like
theorem comes to mind?
you know, yeah, the one that you said the one that has perpendicular lines or stuff like that.
Perfect.
Doesn't come to, yeah.
Because
Could
this
you
one is
say,
tangent.
yeah.
So you're saying this
And,
one?
yeah, isn't it equal to 90 and both sides? Like,
Yep.
something like that. Then you
Perfect.
could say, then after that, can you say that OTB equals to 180 because of angles in the triangle?
I
The
think
sum
you
of the
are
angles.
perfect. Okay, let's take what you said. OTB is 90. That's this one over here because of the tan perpendicular to radius. And then what you said to me was X must just be basically 180 minus the 36 minus the 90 because all angles in a triangle add up to 180.
Yes.
So what is your final answer?
And
What would you get for X then?
54.
54? I agree with you. Absolutely. Perfect. All right. Ladies and gentlemen, we have been working hard for half an hour now, and I like what I'm seeing. So really well done to you. Bonolo, that is fantastic. Bambi, you too. Let us turn on our cameras and let's stand up and stretch so that our brains have a chance to just take a deep breath. So pop on those cameras and join me in a nice stretch. Oh, that feels good.
Come on, guys, please join us in this stretch. Give
Come
your
on,
mind
people.
a break.
I want to see your happy faces.
Yes, turn on
You
your
want to feel like you're part of
cameras.
the family. Ugh.
Oh, come on, Bambi.
Come
Shout out
on.
to Jogo. Shout out to Lesego. Shout out to Bonolo. Shout out
Stretch
to
it out, guys.
William, Nolwazi. Yes, guys. Don't miss out.
Don't miss out. Honestly, don't let me have all the fun. It feels unfair that I'm getting to have all my shoulders on tight. Yes.
Shout out to Jessica. Yes, look at
Oh.
those lovely faces.
Oh, I feel good. I feel fantastic. Or
Ready for the
how
second
they say in
half.
Durban, hundreds. I feel hundreds. It's like actually so interesting, the slang in the different parts of the country. Okay.
Yes.
Now, let us go to a brain break. So today's brain break is the following. And I would like you to tell me what a clock plus 2 sets of bananas times whatever that funny looking thing is. And if you've got the answer, you can pop your hand up and let me know, and I'll confirm it for you, or you can let me know in the chats. Just give your brain a chance to wander for a minute or two and try and figure out what this is going to be. Bambi, I agree. 15 is looking very kind of way to go. Sure, some people are locking in their answers already. I will find out in a moment. Let me make this a bit thicker. So if that's 4 and that's 4, and that's 4 and that's 4 and that's 4, then this would be 3 and 3 and 3.
Mr. S. I think we lost you there, Mr. S.
With the fact that this is 4, 4, 4, there's 2 possible answers here. The one answer is 67, And that will be when this is all 4. So 4 times 15 plus 4 plus 3. However, some people have pointed out that these could be construed as 3 because it looks like they're less. Now, if that was the case, then you would get an answer of 51 as a possibility. But I kind of feel like 67 is the more clear one.
Mr. S?
Yeah.
Jonko's asking about the last shape in the last line, that it doesn't have a square in it, so will it affect the answer?
Oh, flip. I don't think so, no. I think maybe that the graphics just got lost.
Oh, okay.
Well done. Okay, well done, everyone. I like what I'm seeing. And shout out to Teddy and Owami and William who got their chop, and everyone else. We gave that a good effort. Okay, let's get back to our circles. We don't want to leave them for too long. Let us do this one. In this one, I want us to try and find the H, the I, and the K. And this, just to point out that this is a tangent and this is a tangent, and they both come from the common point C. And you have to find for me H, I, and K. So off we go. Jessica, I think you've noticed something important. Yes. Keep those answers coming. Like what I'm seeing, Teddy. Like what I'm seeing, Bambi. Lungelo also. So what I think a lot of students have noticed is that this has to be 70 because angles opposite equal sides. And if that has to be 70, this has to be 40 because of the sum of angles in a triangle. Because of time, I'm not going to write the reasons right now, but you do need to write reasons in the exam. So definitely K is going to be 40. Now, the next thing I want us to think about is what is H and what is I? And what theorems are we going to use for that? I feel like I recognize a theorem here. I like it. Yep. I was also feeling tan chord theorem here somehow. It feels like this, and then that's the chord, and then that would be the angle. I don't know if I think it's 40. For me, I don't think it's 40 for because here's my angle. So I've got the tangent, I've got the chord, but now the actual angle that is subtended by the chord actually goes up here. And so it feels like this one over here is in relationship with this one over here. Yes. So I think H is going to be 70 because of the tan chord theorem. Okay, so now if we've got that this is 70, we need to try and work out I. So we know this is 70. We need to try and work out what I is going to be. I see a couple of people's answers coming in there. What do we think about? Benolo's got an answer. William's got an answer. Nongelo. Okay. So I agree with you. What I think you're doing is you're saying these are tangents from a common point. And so that must be 70 as well. And then because of these two are equal, we say tangents from a common point. And then if those two are 70 and 70, this must be 40 because of the sum of angles in a triangle. So I haven't written out all the reasons, but I like what I'm seeing. And just give me a quick thumbs up if all is well in the world, thumbs down if you're feeling a bit unsure, and then I can move on. Okay. Okay, let's have a look at like a old exam type question, just to kind of, kind of talk through this process. So on the screen, I have an old exam from like 2015 or 2016, and it says, in the diagram, O is the center of the circle. Okay, so we've got the center. The diameter, LR, subtends an angle LKR at the circumference. So what's important there is there's a diameter involved here. N is another point on the circumference, and chords LN and KN are drawn. L1 is 58. Okay, so when I think of this question, what I'm seeing at the moment is I'm seeing a bit of a butterfly. I'm also thinking about the diameter that runs through here. That's kind of what jumps into my brain, but there could be other stuff. I want you guys to try and find for me, with reasons, what LKR is. So LKR, let's see, LKR is that angle up here, or K1 plus K2. It's basically this whole thing together. There's a question. Yeah.
Question here.
Okay, go ahead, Jessica, and ask. Yeah. Hi, Jessica. Can you hear me, Jessica? You unmute at the bottom there.
Hi.
Hey. What do you think it is?
So I'm thinking that K1 plus K2 is equal to 90.
Loving it. Absolutely correct. It's 90. Can you give me the reason?
Isn't it that angle that subtends, diameter that subtends an angle equals to 9? Which theorem? Is it theorem 3?
Yeah.
Not sure.
It's just called, we just say angle in a semicircle.
Oh, okay.
Angle in a semicircle. And you're quite right. This is 90 because this was the diameter over here. Well done, Jessica. That was very good. Okay, so Jessica's helped us with the first one to say that that's 90. The second one I want you to find is R. Now, R is going to be down here. So maybe someone else can help me with finding R. Or you can put it in the chat. Okay, yeah, Jessica, what is your thoughts on finding R?
I'm thinking because LKR is a triangle and we already have two sides, we just add them and separate them from 180.
So you just go minus 90 minus 58, yeah?
Yes.
And what did you get?
72.
Yeah, so 2, no, wait, that looks a bit big. Let me just, or maybe let me just check you. 180 minus 90 minus 58. I get 32.
Oh, 32, sorry.
Yeah, no, that's fine. So 32, and the reason is just going to be sum of angles in a triangle. Okay, cool. And we're on to the last one. What is the value of n going to be? Njongo, I see your hand is up. Should we go to you? What do you think the value of n is going to be?
Sir, no, I wanted to know about the arrow, sir. 58.
The arrow.
Yeah. Let's say, sir, the arrow was on L2. No?
Yes.
And that 58 was still there. Would that mean that like L1 and 2 are both equal to 58 or?
No. So the arrow is this is just making sure you know L1 is the 58 here. So L2 isn't involved. Yeah. But what I'm thinking is, the L2 is not involved here that I can see. What's other question? I see Teddy's hand is up. Teddy, can you help me with N?
N is 32, sir. Angles in the same segment.
Yes, you are completely correct. So this is 32, and the reason is angles in the same segment. And you can notice the butterfly here. You can see this part of the butterfly and this part of the butterfly over here. Apologies that it's so messy, but I'm on a small monitor today. Okay, cool. Ladies and gentlemen, I think that we have just kind of got the sort of into the exam type questions, and I do hope that we've built a good foundation. I do think if you're still writing paper 2, more practice to keep going, but you should have got quite a bit of kind of foundation going forward to kind of take on the past exam questions. Label, could you put the link to the weekly quiz in the chat? And then those students who feel comfortable and want to go and do the quiz, you can go off and do that. However, if there are any more questions, I'm happy to take those now. So will L2 equal 38? One more, sir. Amakalani says one more. Maybe can we squeeze in one more? I'll have a look now. L2 would not be 38, as far as I can tell, because no, I don't actually know what L2 would be right now, but it's not a diameter, so it wouldn't be 32. So we'll have to look at that. Okay. All right. Cool. Ladies and gentlemen, I'm going to call it there for tonight because I do think that we want you to do the quiz. And yeah, it's been great being with you tonight. Thank you so much for spending this time with us, and best of luck for the rest of the week and the further exams. We still will be with you next week. And I would, even if you finished exams, it's a good idea to keep coming because we're going to do past exam paper questions for paper 1 next week. And so those paper 1 questions will definitely come up throughout your matric year. And so, yeah, it's, even if you are finished exams, do keep coming and keep building your knowledge. Okay. Cheers, Jessica. It was lovely to be with you today. And
hi, Jessica.
Yeah.
I
Cheers,
think we have
Bambi.
a question from Teddy Days.
Is there a question? I didn't see it. Where is it? A hand?
I don't want to ask something, but someone asked L2.
Say
L2,
that again.
right? Someone asked L2, sir.
So L2 right now, if I look at this, I don't know. What have we got? L1 is 58. See, the thing is, it's not going to be 32. Why would it be 58? I've lost you on that. That's 90. That's there. What other angles do we have? Unless I'm missing something, I don't see what L2 is going to be, but it's not asked in the question. So I don't know if we have to know. Yeah.
I was thinking of angles in a semi, but now I realize NK is not a diameter, actually.
Yeah, that's the thing. That's why you wouldn't get the 90.
Yeah. Okay, so thank you.
Alrighty. Pleasure, man. Ciao, ciao. Cheers, everyone. Please try hard on the quiz there, and then we will see you on Monday.